Hi, today we're going to be doing Quadratics, Chapter 3 from Additional Mathematics. To start off, we'll discuss what a quadratic equation is. So it is any equation that is in the form ax squared plus bx plus c, where a, b, and c are constants, and a is not equal to 0. And also, we have to keep in mind that the term with the highest degree must be x squared, meaning this statement means that the value of x raised to something, so that value must be 2. So if this was x squared plus 3x cubed, this would not be considered as a quadratic equation because the variable x has the power 3 to it. So therefore, it would not be considered as a quadratic equations. There are three ways of solving a quadratic equation. The first one is called completing the square. The second is use of quadratic formula. The third one is splitting the middle term. And also you'll have to keep in mind that instead of solutions, I'll be saying roots of the equation, or you could say solutions, roots, or the answers to the equation. But roots is used very commonly. So the first method, we'll see what exactly to do. So in this method, we're basically trying to convert the equation in vertex form to the vertex form, which is written right here. This is the vertex form, meaning it will give you the location or the coordinate of the vertex, which is h comma k, where h is the x coordinate of the vertex and k is the y coordinate. So first you'll have to simplify the equation as much as possible, and you'll have to write it in the form ax squared plus bx plus c, where a, b, and c are constant and this is not equal to 0. If this was equal to 0, then it would just be bx plus c, which is a linear equation. So therefore this must not be equal to 0. And we'll have to take a as the common factor. You'll have to write a into x squared plus b divided by ax plus c divided by a. And then we'll have to write bx. Well, just remember these are constants, so you'll have to substitute the values related to your equation. So write this in this form. These two are equivalent, but then this will be more visually, it will be easier for you to identify what to do next. And then on both sides of the equation, meaning on the left and right side of the equation, we'll have to add the term b divided by 2 whole squared, and you'll have to transpose the value of c to the right hand side of the equation and simplify. And then on the left hand side of the equation, you'll have to write it in this form. So what we're trying to do here is write it in the form a plus b whole squared. So this is the method that we use. I will just, the next step is take the square root of both sides and put plus or minus in front of the square root of the constant. This is correct. This basically the reasoning behind the sixth step is that minus 2 whole squared is 4, and also 2 squared equals 4. So therefore we take plus or minus square root. And after that, we'll have to subtract b divided by 2 from both sides. Okay, let's solve a few equations to make sure this is engraved in your mind. So we'll start with this equation, the first one. So the first step was take a as a common factor, but then here a is 1, so we don't have to really take it. So the next step was that write bx as 2 into b divided by 2x. So let's write that. Implies x squared plus 2 into 4 divided by 2x plus 1 equals 0. Let's first simplify this. This is 2 into 2x plus 1. Okay, the next step was to add b divided by 2 whole squared to both sides. Here b divided by 2 it's the value within the brackets. Remember that, not this one. It's this one. So we'll have to write b divided by 2 whole square to both sides. And we'll have to also transpose it this side. So first we'll actually do this. 2 squared plus 1 equals 2 squared. This wouldn't matter because we are adding this to both sides. Even if we cancel, it would remain the same value. So we're just adding to both sides. And then we'll have to transpose this to this side. This is x squared plus 2 into 2x plus 2 squared equals 3. 4 minus 1, 3. So you might notice that it's in the form of a squared plus 2ab plus b squared. This equals a plus b whole squared. So this is what we're essentially trying to do. So we can write this as x plus 2 whole squared equals 3. And now what we're supposed to do is take the square root. So it implies x plus 2 equals plus or minus square root of 3 implies that x equals minus 2 plus or minus square root of 3. So these two are the answers. The first answer is x equals minus 2 minus square root of 3. The second answer is minus 2 plus square root of 3.
Okay, so let's solve this second equation. So over here, I'm actually going to change the equation a little bit. So just I'll just write this as minus 3x squared plus 15x plus 5 equals 0 implies that minus 3 into x squared minus 5x minus 5 divided by 3, and this will equal 0, and we'll just cancel that out because if we divide this side by minus 3, then it will still remain 0. So x squared minus 5x minus 5 divided by 3 equals 0. So now let's solve this. So we'll have to write this as x squared minus 2 into 5 divided by 2x minus 5 divided by 3 equals 0. And now we'll have to write the square of this. We'll have to add the square of this to both sides. Implies x squared minus 2 into 5 divided by 2x plus 5 divided by 2 whole squared. And we'll first transpose this to this side. Simply 5 divided by 3 plus 5 divided by 2 whole squared. Okay, the right side of the equation, we can simplify this to 5 divided by 3 plus 25 divided by 4 implies that x minus 5 divided by 2 whole squared equals, I'll just use the calculator to find this out. 5 divided by 3 plus 25 divided by 4, that is 95 divided by 12. 95 divided by 12. And now we'll do square root of both sides. Implies x minus 5 divided by 2 equals plus or minus square root of 95 divided by 12. And now we'll add 5 by 2 to both sides. So x equals 5 divided by 2 plus or minus square root of 95 by 12. So this is our answer for this equation. If you want, we could solve this also. I'll just do that right now. So that would be 3x squared plus 12x plus 5 equals 0. This implies that minus 3 into x squared minus 4x minus 5 divided by 3 equals 0 implies that x squared minus 2 into 2x, because 4 divided by 2 is 2, minus 5 divided by 3 equals 0. Now let's write x squared minus 2 into 2x plus 2 squared equals 5 divided by 3 plus 2 squared. This implies that x minus 2 whole squared equals 5 divided by 3 plus 4 is 17 by 3. This implies that x minus 2 equals square root of 17 divided by 3, and put plus or minus, and then implies x equals 2 plus or minus square root of 17 divided by 3. So this is our final answer. Yeah, I've solved these three questions, and now let's move on. The next part is, oh, actually you can try these problems on your own. Try to pause it, and then, and then I'll maybe solve one or two, and then I'll just show you the answers. Okay, so now I will first answer these two questions, and then I'll reveal the answers. So I'll just transfer it here. So the first one, what you'll have to do is, most of the work is already done for you. All you'll have to do is transpose it this side and just take the plus or minus square root of the answer. So this implies that x plus 1 whole squared equals 10 implies x plus 1 equals plus or minus square root of 10 implies x equals minus 1 plus or minus square root of 10. So that is how you solve these type of equations. And then let's do the next one. The next one I was planning was this one. This may seem complicated, but it's very easy. So all you'll have to do is you'll have to multiply the terms by x so that we don't have to deal with this. So what we'll have to do is multiply by x. 3x into x is 3x squared. This will be minus 2 equals 4x. Now let's transpose this to this side. Implies 3x squared minus 4x minus 2 equals 0. And then let's take a as a common factor. So 3 into x squared minus 4 divided by 3x minus 2 divided by 3 equals 0. Yeah. Now let's divide both sides by 3. I mean, it wouldn't matter, but you could do it either way. You can keep it or remove it. So it would be x squared into 2 into this divided by 2. So 4 divided by 3 divided by 2 would be 4 divided by 6. That is 2 divided by 3x minus 2 divided by 3 equals 0. And now let's take the square of this 2 divided by 3 to both sides, and let's transpose this to this side at the same time. So implies x squared minus 2 into 2 divided by 3x plus 2 divided by 3 whole squared equals 2 divided by 3 plus 2 divided by 3 whole squared. This implies that x minus 2 divided by 3 whole squared, this would equal 10 by 9. And now let's take square root of both sides. X minus 2 divided by 3 equals plus or minus square root of 10 divided by 9. Square root of 10, we'll write it as square root of 10 itself. Let's write divided by 3. And now we'll transpose this term to that side. Implies 2 divided by 3 plus or minus square root of 10 divided by 3. So that's our final answer. Okay, now I'll reveal the answers for the rest of them. Okay, so to start off, we'll be starting with the quadratic formula. So it basically states the quadratic formula. I will tell you how it was derived. So the statement is if ax squared plus bx plus c equals 0, where a is not equal to 0, then x equals minus b plus or minus square root of b squared minus 4ac whole divided by 2a. So instead of having to do the completing the square method by using such a long method, what you could do is just use the formula. B is the coefficient of x, A is the coefficient of x squared, and C is the coefficient or the constant of x to the power of 0. X to the power of 0 would be 1, by the way. And yeah, so this is the formula. I will tell you how it was derived. We use the same method here, like how I've outlined. We'd basically do the same thing. So I'll just do it now. Okay, let's do it. It was ax squared plus bx plus c equals 0. Now let's take a as a common factor. So a into, yeah, this one. Now let's just divide by a. So we would get this. And this is what we write, b divided by 2a x plus c divided by a equals 0. And now let's write this. This would be plus 2 divided by b divided by 2a whole squared equals minus c divided by a plus b divided by 2a whole squared. So what we'd write this as x plus b divided by 2a whole squared equals, let's simplify this. So it would be c divided by a plus b squared divided by 4a squared. And then we'd write this, we can multiply this by 4a, then divide by 4a. So we can write 4ac divided by 4a squared plus b. Now let's simplify this even further. So this would be b squared minus 4ac whole divided by 4a squared. Okay, so now let's take the square root of this. X plus b divided by 2a equals plus or minus square root of b squared divided by 4ac divided by square root of this. So what we can write square root of 4ac, no, I mean square root of 4a squared as 2 into a. So we'll just write 2a, and now we'll have to subtract both sides by this term. So therefore, x equals minus minus b by 2a plus or minus square root of b squared minus 4ac divided by 2a. Since this is common, we can write this as minus b plus or minus square root of b squared minus 4ac whole divided by 2a. So this is the formula right here. Minus b plus or minus square root of b squared minus 4ac whole divided by 2a. So the next point I've written is that the sum of the roots of the equation equals minus b by a. So I'll just show you how it's that. Okay, so we know that the roots of the equation are minus b plus square root of b squared minus 4ac whole divided by 2a and minus b minus square root of b squared minus 4ac divided by 2a. We can write this as minus 2b by combining these two, by adding these two. Minus b equals minus 2b, and these two would cancel out because this is plus and this is minus, so that would just remain as 0 divided by 2a. If we cancel these two, we'd get minus b by a. So that's how this was derived. So what we'd have to do is minus b plus square root of b squared minus 4ac divided by 2a into minus b minus square root of b squared minus 4ac divided by 2a. So we know that a squared minus b squared equals a minus b, a plus b or a minus b, either way, into a minus b. So we could use that here. So this would be b squared minus square root of b squared minus 4ac whole squared. And now we could just multiply these two normally. That would be 4a squared. And now that would be b squared minus b squared minus 4ac divided by 4a squared. So this would equal, we'd cancel these two and we'd write the plus, negative and negative would become plus 4ac divided by 4a squared. If we cancel these two, we'd get a divided by c into a into a. We can cancel these two to get c by a. So yeah, that's the answer. That's the product. And minus b by a is the sum, and the product is c by a. I also wanted to show you the types of functions and their names. So if the highest degree of the variable is 1, then it's called a linear equation. If it's 2, it's a quadratic equation. If it's 3, it's cubic. And if it's 4, it's quartic. And then I'll just show you a few examples. Okay, let's just take this example. We know that the formula x equals, actually, you know what? Let's just make this a little more clear for us. We'll just write a equals 2, b equals 3, c equals minus 6. And now it will be very simple. All we got to do is plug in the values. So we know that x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Here minus ba would be minus 3 plus or minus square root of b squared. B squared is 3 squared, that is 9, minus 4 into 2 into minus 6 divided by 2 into 2. So this would be minus 3 plus or minus square root of 9. So we'd cancel the negative value. So that would be 24 into 2. 24, yeah, 24 into 2 is 48. 48 plus 9 is 57 divided by 4. So that would be minus 3 plus or minus. So let me write it down here. So the answer is minus 3 plus or minus square root of 57 divided by 4. Okay, so this is the answer. You could third and last method of solving is called splitting the middle term. So here let's look at case 1, ax squared plus bx plus c, where a and b are positive, or you could also say where a and b are negative. Either way, you'll have to get AC as a positive number. So that's where, sorry, this is supposed to be C. Yeah, where AC and are positive. So here you'll have to find the value of AC, which has to be positive. And the value of B must be the sum of the two values whose product is AC. This may be confusing, but let's just take a few examples. Let's say AC equals 8. So we'll have to find a factor of 8 whose sum is also 8. I hope that's clear. Whose product is AC. So let's try. So we have the number 8. So we'll have to find two values whose product is 8. So we can say 2 into 4 equals 8, or 1 into 8 is also equal to 8. Depending on the middle term, let's say if the middle term was 6, then we'd have to consider 2 into 4, because 2 into 4 is 8. 2 plus 4 equals 6. So like that, we'll try to find, I'll just give a few more examples so that it's very clear. So let's say 15, and we'll say 15. AC equals 15. AC equals 15. So let's say AC equals 15. AC equals 15. So what two values when multiplied give you 15? We could write 15 into 1. We could write 3 into 5. Yeah, those two are the only ones. And imagine if the middle term b was equal to 16, let's say. Then we'd have to use this because 15 plus 1 equals 16. But if b was 8, then we'd have to use this because 3 plus 5 equals 8. I hope this is clear. Let's just do maybe two more examples. Let's say AC is 20. 20 has a lot of factors, so we'll just go through every single possibility. We could write 20 into 1. We could write 2 into 10. We couldn't write 3. We could write 4 into 5. And the thing repeats again, so we don't have to write 5 into 4, etc. So these are the three possibilities. Imagine if B was 11, not 11. B was 21, and we'd use this because 20 plus 1 equals 21. 2 into 10, that's 12. So if B was 12, we'd use that. And if B was 9, we'd use this. Let's go for a very large number. Let's say AC was 60. Yeah, we'll have a lot for that. So first, 1 into 60, 2 into 30, and 3 into 20, 4 into 15, 5 into 12, 6 into 10, 7, no, 8, I don't think so, 9, no, 10, yeah, we'll repeat again. So imagine if B was 61, then we'd use this. This would be 32. Yeah, let me just write this so it's more clear. So this would be 61. B, this is the value of B, remember? So it would be B equals 61, B equals 32, B equals 23, B equals 19, B equals 17, B equals 16. Yeah. So I hope you have gotten this, and let's move on to case 2. So if A, C have different signs, meaning A has -1 and B has A has a positive sign and C has a negative sign, we'd use this method. So basically, if AC is negative, we'd use case 2. If AC is positive, we'd use case 1. So here, what I'm trying to say is that the value of B must be the difference of the two values whose product is AC. It's very similar to the other one. We'll just go through examples so it's much more clear. Let's take AC as, let's take -12. Okay, so -12 we could write as -1 into 12. We could write 12 into -1. We could write -3 into 4. We could write 4 into 3. And we could also write 2 into -6 or -2 into 6. So now we'll add these two. So this would be 11, this would be -11, this would be 1, this would be -1, this would be -4, this would be 4. Let's actually see how to solve these type of equations. Okay, so we have x squared plus 3x plus 2. What is AC? It's 1 into 2, that is 2. So what are the factors of 2? So since it's positive, we're using case 1, remember? So it would be, there's only one, there's 2 into 1. 2 into 1 equals 3, which is B. So that's correct. So now we have gotten these two values, right? The number that we have added, we just have to write x and x. We'll just have to multiply x and x. So we'll split the middle term to write 2x plus x. And we just write it this way. I hope that's clear. This is really important. Just make a note of it. So it implies x squared plus 2x plus x plus 2. These two are equivalent and we have just split the middle term. That's why it's called splitting the middle term. So now we'll just have to factor it. So first take these two. Just forget about that. Just factor this. We write x into x plus 2. That's how we're doing it. Now, the common factor of x and 2 is 1. So we write 1 into x plus 2. And now we have to factor it. So it would be x plus 2 into x plus 1. I hope this is clear. And let's just solve a few examples. Okay, first we'll find AC. Let's write AC equals 16. Oh yeah, if you get negative number also, it doesn't matter. It's the same procedure. So we'll have to find the values. So we could write 16 as minus 1 into 16 into minus 16 also. This is also valid. If the number is negative, try to write negative into negative. But if this was plus, you would have written 1 into 16. So now it's negative 1, negative 16. We have multiplied that and we get 16. So now we have to add these two. Minus 1 plus minus 16. That's minus 17. So that's what we've got. Our two values would be minus 1 and minus 16. So now let's write this as x squared minus 1x minus 16x plus 16. Yeah, let's factor this to be x into x minus 1 minus 16 into x minus 1. This implies that x minus 1 into x minus 16. So we have factored this. Imagine this was equal to 0. If you wanted to find the roots of the equation, we just write x minus 1 equals 0, implies x equals 1. Similarly, x minus 1 equals 0, implies x equals 16. This is how we find the roots. Let's solve this one more equation. Okay, let's just use this color. That's right. AC equals 3 into 8. That is 24. Now we have to find the factors of 24 whose sum is 10. So we'll write all the possibilities down. What is 1 into 24? This would be 25, so we can't take that. Since it's positive, we are taking only positive numbers. Then we write 2 into 12. That would be 24. No, that would be 14. That's wrong. Then we write 3 into 8. That is 11. Then we write 4 into 6, which is 10. We've got our two values, which is 4 and 6. Now let's split the middle term. So that would be 3x squared plus 4x plus 6x plus 8. Now let's factorize it. X into 3x plus 4 plus 2 into 3x plus 4 implies 3x plus 4 to x plus 2. If we want to find the roots of this, we equate it to 0. X would be minus 4 divided by 3 and x equals minus 2. Okay, so these are the problems for you to try. So first solve these. I will solve each and every one of them because this is the most complicated out of the three methods. So therefore, I'll be solving 5 more equations. Okay, now let's start with this. Okay, so the first equation was x squared plus 19x plus 60. So we'll have to factor this 60. There is no coefficient of a. We just write AC equals 1 into 60. That is 60. Now we have to find the values. 60 can be written as 1 into 60, which gives 61. That's not correct because we have to find 19. Then we have 2 into 30, that would give us 23. 32. We have 3 into 20, that would give us 23, which is also wrong. And we have 4 into 15, which is 19. So we got our two values. Let's solve this now. X squared plus 4x plus 15x plus 60 implies x into x plus 4 plus 15 into x plus 4 implies x plus 4 into x plus 15. So this is our answer. If you wanted to find the roots, we'd equate this to 0. We equate first this to 0, then this to 0. Then we'd get the roots. Okay, so the next example, yeah, that's the answer. And then the next one is x squared minus 12 minus 45. So we write the equation x squared minus 12x minus 45. Yeah. So this is case 2 because AC is negative, as we can clearly see. It's minus 45. Okay, so this could be written as minus 1 into 45. No, I mean, it wouldn't work. Just let's do 5 into, what's 45 divided by 5? It's 9. So we write minus 9. No, that's not correct. We could write 15 into negative 3. Yeah, we could write that. Actually, yeah, we could write minus 15 into 3. So we got our two values, which is minus 15 and 3. Now let's solve the equation. It's x squared minus 15x plus 3 minus 45 x into x minus 15 plus 3 into x minus 15 implies x minus 15 into x plus 3. This is our final answer. Yeah, that's our answer too. And let's solve the third one. AC equals minus 60. We got to find 11, so we'll find all the possibilities. It cannot be minus 1, so we'll look at minus 3 into 20. No, this is not possible. Then we have 5 into 12. That's not the right answer. Then we have 6 into minus 10, which is also not the answer. Then we have 3 into 22 into 30. 5, 6, 7. We don't have 8. We don't have 9. 60, right? So 60 divided by 2 is 30. 320, no. Maybe 4. Yeah, 4 and 15 would work. So we'd write minus 4, 15. If we multiply these two, we get AC. We add these two, we get B. So we'd write 6x squared minus 4x plus 15x minus 10. Now we'll just have to simplify it and factorize it. This is our answer. Yep, that's the answer. Let's solve the next one. Next one is 2x squared. 2x squared minus, we have 2x squared minus 17x minus 30. Okay, we'll have to find AC. AC is minus 60. Yeah, so I think I got it. We have minus 3 into 20, or the other way around, minus 20 into 3. Then it would be 2x squared minus 20x plus 3x minus 30. Then 2x minus 10 plus 3 into x minus 10 plus x plus x minus 10 to 2x plus 3. So that's our answer. Yep. And we have this equation. AC equals 24 and then 14, right? So that's maybe, so we have 2 into 12, yes, that's 14. So we write 3x squared plus 2x plus 12x plus 8. Now we'll have to simplify it and factorize it. X into 3x plus 2 plus 4 to 3x plus 2 plus 3x plus 2 to x plus 4. Yes, that's our answer. So that's all for part 3, and thank you.
The next part of the chapter is called as nature of the roots. So for this quadratic equation, ax squared plus bx plus c equals 0, the solution or the roots is minus b plus or minus square root of b squared minus 4ac divided by 2a. So this is the solution. In this part of the solution, this part of the solution is what we call as the discriminant, the b squared minus 4ac part. And this discriminant is represented by the Greek alphabet delta, which is a triangle, just a triangle. Yeah. And then here we're going to predict whether the roots are going to be real or are they going to be imaginary by looking at the magnitude of the discriminant.
So if the discriminant is less than 0, then the roots of the equation are conjugate complex numbers, meaning it's comprised of real and imaginary numbers. Moreover, it does not exist on the Cartesian plane. You can just write it as there are no real roots. The reasoning behind this is very simple. So we know that the square root of a negative number is undetermined. So therefore, when this becomes negative, there are no dual roots. The second part is if the delta or the discriminant is equal to 0, the roots are real and equal. The equal part I'll just explain right now. So if this becomes 0, then square root of 0 is 0. And plus or minus 0, it wouldn't really matter, like plus 0, minus 0. So therefore, the answer would just be minus b by 2a. So therefore, the roots would be real and equal. And by imaginary, I mean square root of minus 1. It's also represented by I. Okay, the third part is if the discriminant is greater than 0, then the roots are real and different. It's very important to be able to distinguish between the delta being equal to 0 and being greater than 0. If it's 0, then it's equal. If it's greater than 0, it's different. Like the two roots will be different. For example, let's take this. We have the equation 4x squared plus 5x plus 3 equal to 0. So here the discriminant would be b squared minus 4ac. It's 5 squared, which is 25, minus 4 into 4 into 3. 4 into 4 is 16. Into 3 would be 48. And when we calculate this, we get minus 23. So since the magnitude of the discriminant over here is negative, we can conclude that there are no real roots. Let's look at some key points that will be required for the next few topics we're going to do under quadratics. First of all, the graph of a quadratic equation is called as a parabola. The graph that we get, there's only two possibilities that we can get. Either it's upward facing or it's downward facing. This is how it's drawn. Like there are no other possible options. So this is called as a parabola or a quadratic function graph. So the next point is the point where the graph turns is called as the vertex, meaning the highest point over here and the lowest point over here is known as the vertex. Um, so if the graph opens upwards, the vertex is minimum turning point, and therefore the graph will be concave upwards. So if you look at this value determines whether the graph is concave downwards or concave upwards. If this value is positive, then it's going to look something like this. It's going to be upward opening, also known as concave upwards, and the vertex will be the minimum point, because as we can clearly see, I'll draw a better graph here. As we can see, this is the bottom point. There is nothing below this, so therefore it would be the minimum point. So if a is less than 0, meaning it is negative, it will look something like this, and the vertex will be a maximum point.
Okay, so the next point states that the vertical line that passes through the vertex is called the axis of symmetry. As this is very clear, the vertex, if you draw a line here, these two are supposed to be symmetrical. Something like this, even over here. And the next point states that the point where the graph crosses the y-axis is called as the y-intercept. It's the point where x equals 0. For instance, if this is the graph, then this would be the y-intercept. And the point where the graph crosses the x-axis are called the x-intercepts, or they're also called as the roots of the equation. So now I will link the nature of the roots with this, with the graph. So if discriminant is greater than 0, the graph cuts the x-axis at exactly 2 points. There will be two x-intercepts. And if discriminant is equal to 0, then there will be one x-intercept. Just one intercept. Just one x-intercept. And if delta or the discriminant is less than 0, then the graph will not have any x-intercepts, and it will never cross the x-axis. Okay, so the next topic is the vertex form. As we previously discussed, the vertex of a parabola is the point where the parabola crosses its axis of symmetry. It's also known as the turning point. And if the coefficient of the x squared term is positive, meaning a is greater than 0, the vertex will be the lowest point on the graph, and it will be concave upwards. And if the coefficient of the x squared term is negative, meaning a is less than 0, the vertex will be the highest point on the graph, and furthermore, it will be concave downwards. Okay, as we discussed in completing the square, this is how you can write it. It's also known as the vertex form, the a into x minus h whole square plus k, where h and k is the coordinate of the vertex, and the x coordinate is minus b by 2a, and y coordinate is minus of b squared minus 4ac whole divided by 2a. Okay, we know that the discriminant is b squared minus 4ac. So therefore, we could write the y coordinate of the vertex as minus delta, which is the discriminant divided by 4a. This is much more simple to remember. So this is you can remember this. And let's just try a few things, a few equations. 5x squared plus 4x minus 9. Okay, so now we know that a is 5, b is 4, and c is minus 9. A is 5, b is 4, c equals minus 9. So the x coordinate will be minus b by 2a, which is minus 4 divided by 5 into 2, that's 10. That is minus 2 by 5. And the y coordinate would be minus delta divided by 4a. Over here, b squared minus 4ac equals 16 minus 4 into 5 into minus 9. That's 16 minus 20 into minus 9. 16 plus 180, that would be 196. And divided 196 minus 196, because it's minus the discriminant, divided by 4 into 5, and that will be minus 49 divided by 5. Yeah, that's the answer. Okay, so the x coordinate of the vertex would be minus b by 2a. So that would be minus of minus 16 divided by 2 into 9. So that would be 16 divided by 18. You could simplify it further to 8 by 9. Now let's find the y coordinate of the vertex. It's minus discriminant divided by 4a. So that's minus of b squared over here is 16 squared. And 16 squared is 256. Minus 4 into AC divided by 4 into 9. So if we use the calculator to find that, that would be minus 112 divided by 4 into 9, and this would be minus 28 divided by 9. So this is the answer. The vertex would be 8, 9, minus 28 by 9. This is our final answer. Let's move on to the next topic. So the next topic is how to graph a quadratic equation. There is not really an exact method for it. You'll just have to find two important things of a graph, and then you'll have to sketch. I've given two examples here. For instance, you could probably find the axis of symmetry by using x equals minus b by 2a, and you'd find the axis of symmetry, and then you could substitute the value of y of the y-intercept, and then you could state the value of the y-intercept, which is c, and you could find the x-intercepts by solving this equation by either of the three methods I've outlined in the previous slides. So here you'd have the axis of symmetry, you'd have the y-intercept, and you'd have the x-intercepts, and hence it would be easy to graph it. I'll probably show you a quick example. So imagine if the x-intercepts were 1 and 2, and the y-intercept was maybe 4. So what you'd do is this would be 1, this would be 2, and this would be somewhere 4. And we know that the axis of symmetry here would be 1.5, because it's right in between the sum of the x-intercepts divided by 2. So yeah, you'd have to connect these lines. You'd also have to find the vertex, and you'd probably get something like this, and you'll just have to connect them. Something like that. And this should be symmetrical to this. So that's our final answer. And then you'll either have to find the vertex, then either find x-intercepts or y-intercept and connect the points. This is how it is. Just you'll have to find that. So the next topic is positive definitive and negative definitive quadratics. Positive definitive quadratics are quadratics which are positive for all real values of x, ranging from minus infinity to infinity. So it belongs to all real values, and therefore ax squared plus bx plus c would be greater than 0. A test you can do to find if a quadratic is a positive definitive is if a is greater than 0, meaning it's an upward opening parabola, and such that the discriminant is less than 0. So we know that if a discriminant is less than 0, meaning it does not have real roots, so therefore it never crosses the x-intercept or the x-axis. So it won't have any x-intercepts, and it will never cross the x-axis. So therefore this statement makes sense. Positive for all values of x. So this is a test you could do. And similarly, negative definitive quadratics are quadratics which are negative for all values of x. So therefore ax squared plus bx plus c would be less than 0. Similar to the positive definitive quadratics, you could do a test to see if it's a negative definitive. All you need to do is check if a is less than 0. If a is less than 0, we know that it's a downward opening parabola. And the discriminant must be less than 0, meaning it should not have any real roots. And yeah, this is the condition for a negative definitive. And this is the graph of positive definitive, meaning it never crosses the x-axis, and it's positive for all values of x. And then we have this, it's negative definitive. Okay, so the next topic is where functions meet. So the graphs of a quadratic and a linear function either meet at 0 points, 1 point, or 2 points. So all we need to do is equate the equations together, and we'll have to find the discriminant. And then if the delta is greater than 0, we can conclude that they intersect at 2 points, at exactly 2 points. But if the delta is equal to 0, they intersect at 1 point, and if the delta is less than 0, they don't intersect at all. So now let's try an example. Okay, so this is our question. Let's equate the quadratic and linear equation. Minus 3 equals 6x minus 4. We can transpose the terms to this side. This implies that 5x squared minus 2x plus 1 equals 0. Over here, a equals 5, b equals minus 2, and c equals 1. Therefore, the discriminant or the delta is b squared minus 4ac. This equals minus 2 whole squared minus 4 into a is 5, c is 1, implies 4 minus this would be 20. This equals minus 16. Since minus 16 is less than 0, the linear equation and the quadratic equation don't intersect. Okay, so now let's move on to the next topic. It's problem solving with quadratics. It's a pretty simple topic. So what we'll need to do is translate the information into algebra using variables. And step 2, write down what the x variables mean, like x and y variables, I mean, and write down the units if there are any. Step 3, solve the equation by using a suitable method, any of the three outlined in the video. And now let's just solve this simple question. So now let's solve this simple problem. It states that the sum of a number and its reciprocal is 26 by 5. Find the number. So I've written it down. A reciprocal means 1 divided by that number. So first we can multiply all the terms by 5. So that would be 5x plus 5 divided by x equals 26. Now let's multiply by x. So 5x squared plus 5 equals 26x implies 5x squared minus 26x plus 5 equals 0. Now I think that the simplest method to solve this would be using third method, splitting the middle term, because we know 5 into 5 is 25. So minus 25 into minus 1 would be 25, and the sum would be minus 26. So it would be 5x squared minus x minus 25x plus 5 equals 0, plus x into 5x minus 1 minus 5 into x minus 1 implies 5x minus 1 into x minus 5 equals 0. Therefore, 5x minus 1 equals 0 implies x equals 1 by 5, and or x equals 5. Okay, so now we'll just see if this is right. So 1 divided by 5 plus 1 divided by 1 divided by 5 would be 5. So that this would be plus 25 by 5, 26 by 5. So that's right. And now 5 plus 1 by 5. This is also 26 by 5. Therefore, this is correct. And we are done with quadratics for additional math chapter 3.